So the method seems very powerful. So one then wonders, well, can we always use this residue method to find sums? And the answer is no. And a simple example is this case when p is odd. Because when p was even, in the example, we had no problem, because basically we were dealing with the sum. We have an expression for this. But you see, if we expand this, then what do we get? 1 over 1 to the p plus, I'll do plus or minus, then we've got 1 over minus 1 to the p plus 1 over 2 to the p plus 1 over minus 2 to the p plus etc. So you see, the problem is that if p is odd, then we preserve the minus sign, and these two terms cancel, these two terms that cancel themselves. So this is equal to 0 if p is odd. So we can't relate this in any way to the sum, our expression for residues, since our expression of residues will give the answer 0. And this, in a way, is to be expected, because in fact, if you take, I should mention the p equals 1 case doesn't converge, but the p equals 3 case, this function here is actually also known as the zeta function of p. And the p equals 3 case, zeta 3, is a number like pi, which there's no other way to express it except in terms of its definition. It has in fact been proved to be irrational, but it can't be expressed in terms of anything else. So it's hardly surprising that there's no way with residues to get this value.